So this is going to look at the idea of adding complex vectors. And by complex vectors, I mean if we had a situation where we had, let's all have all these be displacements. We'll say that's 15, and then we walk another 15, and then we walk another 15, and then we walk 10 straight down, and then maybe 5 to the left, right? So if we had to add all these vectors up, because we've added them head to tail already, we can just say that our total here is from where I start to where I end. So this is my total displacement. Now, how would I actually find the two parts that I need to find the total, right? Remember, a vector has both a magnitude, the length of this arrow, as well as a direction. So how I like to do that is by using the idea of components. And so the first thing is I'm going to break each vector into x and y components. So because there's no, we have values, but I'm not going to worry about angles. I'm just going to look at this, right? So this is my x, and let's actually give each of these a letter. So A, B, C, D, and E, right? So this here is the x of A, right? The x of B is here. Oh, so this is a component, right? So this is the x of B. The x of C would look like that. The x of D is actually 0 because it's going straight down. There is no x component here. And then the x of E is to the left. So, right, and what we can understand is that the total x, so this is my x total, and what this means is that xa plus xb plus xc plus xd plus xe equals x total, okay? And so a few things. Xe is going to be negative, right, because it's going in the negative direction, and then xd is already 0. And so the idea is we're just adding all these up. Yes, this is a negative. Yes, this is 0, but all these together add up to my x total. So this plus this minus this, right? And that's how we get to this length here of x total. Same idea for my y directions. So this is going to be my y of A. Y of B here would be 0. This would be my y of C, and that's a negative value. Y of D, and again, that's a negative value as well. And then y of E would also be 0. And what we can see is this is my y total. But again, we're just going to add all these up, right? So the y of A plus the y of B plus the y of C plus the y of D plus the y of E equals my y total. So this minus this, right? So those two actually cancel out. And then we have y of D, and then there is no y of E, and there's no y of B. So it really, this breaks down to y of A and y of C cancel each other out. And so really y of D is what creates y total. Now, once we do that, so that's kind of 2. So add to find x and y total. Now, why we do that is because then we can use Pythag to find total. So the idea is, again, if this is x total and this is y total, well, I've just created this nice right triangle, and to find total then, which is my vector. So again, notice component, vector, filled in head, right? What I would need to do is I would just need to do x squared, so x total squared plus y total squared equals total squared. And so really I'm going to square root both sides. So total then would equal the square root of x total squared plus y total squared. And again, I'm doing this, I'm not using numbers because every problem is going to be a little different, but it's the process that we need to understand of how we get there. So these three steps here, this is how I'm going to find the magnitude of the total vector. Okay, so those are the three steps. It's always the same. If I break each individual vector into their x and y components, then I add up their x and y components to find the x and y totals, and then I can use Pythagorean's theorem to find the actual total. Okay. Well, because this is a vector, right, and we're adding complex vectors, the other aspect I need is I need this angle here. So this is going to have an angle right here. So then the fourth step would be to find the direction of total. And how I would do that is, this angle here. Now, if I have all three sides of a triangle, not four, x total, y total, and total, I could really use sine, cosine, or tangent. Usually, we're just going to use x and y total. And so that's my opposite and my adjacent. So the tangent of theta would then equal my opposite, which would be y total, over my adjacent, which is x total. Now, I need to solve for theta, right? And so the math with this, it's not tricky, but the idea is essentially I'm dividing each side by tangent. Okay, and so while that can confuse students, remember the same as dividing something is the same as multiplying by the reciprocal. So I like writing it that way. In that, let's make it so that we multiply each side by tangent inverse. Tangent inverse, right? And so what that does is that cancels out my tangents on this side, and I'm left with theta equals the inverse tangent of y over x, right? So if I plug that into my calculator, no matter what the numbers are, this is how I would find my my theta, or my direction, right? So this here is to find the direction. So when we put all this ideas together, and again, this makes the most sense when we're actually going through problems, but the idea of I can add any combination of vectors, right? This is 1, 2, 3, 4, 5. I could add 2. I could have 20 if I can follow these steps. 1, break them into their x and y components. 2, add those components together. All the x's add together, all the y's add together to find my totals. And then I can use Pythagorean's theorem to find my total. And the process there is here. Then to find the direction, I'm simply going to use one of my sine, cosine, or tangent rules, and then I can find direction. And that gets me both pieces I need for any vector, right? The magnitude as well as the direction.